start this thing. Okay, we're recording. What's going on, Algebra 2 students? I have no idea why I always do the what's going on, or I do this, but I always do, and I always call everyone dudes. What's going on, dudes? Let's get this party started. I never say dudettes, but I always refer to the 1700 definition of dudes in terms of a fashion-forward thinker. So, I mean, that kind of classifies both the boys and the girls. Why don't we do this? What I decided to do was I kind of took a survey with the students, and you guys saying that the class is going a little bit too quickly. Some of you are saying, some of you are pretty happy with how fast the class is going. Would it be all right if I slow down the class just a little bit? I think some of the students are getting a little stressed out. And I don't mind kind of pushing things back maybe a day or two or three.
I was kind of stressed out through the first Algebra 1 review.
And then what I'm going to also do is today what I want to do is I want to take this opportunity while we're here to finish off the rest of Chapter 2. I just want to get through that lecture. And then once we get through that lecture, once we figure out all of those things, I'm going to basically say, all right, the rest of Algebra 2 lab is basically, why don't we just work out some questions? Why don't we go in? I heard there's some problems with my quizzer. We'll answer those problems. For the quizzer specifically, I try not to give you the answers. A lot of you folks have been getting tutoring from me, and I've just basically been going in and giving you freebies, right? Like I've been basically, okay, fine, let's solve that problem straight from your homework. Oh, Mr. Balde just did your homework for you. Obviously, I'm going to try to stay away from doing that specifically, but I don't mind kind of giving you an idea of which direction to go or unstucking you. Because I think that a lot of students say, oh, it's easy when Mr. Balde solves it. I mean, he just stands up there and just, oh, this is what you do, blah, blah, blah. And I write it down and I get it, and then I go home and I'm just like, oh, man, where do I even begin? Right? Is that how you feel? I don't know. Or that's not how you feel. And you guys are like, oh, I'm cool. All right. So, here's what I'm going to do.
Well,
yes?
Diamond suggests or do an example that's similar to...
See, I thought the examples that I do in class are similar.
Well, yeah, but like, I think she means like, maybe instead of giving away too much by just giving freebies all the time, like just kind of take a problem that's very similar.
Okay, I'm down with that. I think a lot of people are also having trouble with my style. Like they don't understand why I format something the way I do. And I'm going to prepare you guys for something, just giving you a heads up. I'm not sure if this kind of came up in your homework yet or not, but here's something I can think of off the top of my head, is something like ax squared plus bx plus c. What I'll do is I got to figure out a way for you folks to type up the equations or like give me the answer and say the answer is something like 5x squared plus 3x plus 4. How do I have you type that in a computer, and how do I have the computer grade that? Because you can't type an x squared into a computer. Does that make sense? You're trying to type math into it. So what I do sometimes is I'll ask you the question 3 different times. And I'll just say, what was A, what was B, and what was C? All you do for the answer for that is A is 5, B is 3, and C is 4. That's it. Does that make sense?
Yeah, I was seeing all these homework assignments with like twice the amount of problems.
Yeah, the homework assignments have like, it will have 3 parts for the same question, but all I'm trying to do is get a way for you to tell me the coefficients that's supposed to go in there. And the coefficient means the number in front of the x squared term, or the number in front of the x. And that's something that people a lot of times screw up as well. If I say, well, what is the a term? They always tell me, oh, it's 5x squared. No. The a is the number part of the x squared thing.
Yeah, because a can't be 5x squared if you already have an x
Right.
squared.
You have the x, right. The general form, the general blanket statement here is ax squared plus bx plus c. The a is a number, just a number, no letters associated with it. Got it? Now that's not always true. Later on we can throw in some letters that are associated with it. Let me give you do one right off the top of my head. What about like x squared or negative x squared plus 4? What is A, B, and C of that?
1, 4, and 1. 0, and 4.
1, 4, and 0. 1, 0, and 4. Which one? Yeah.
1, 0, and
Negative 1, 0.
There we go. It's A is negative
Because-
1, B is 0, and C is 4 in this particular case. So if this is what you guys get as an answer, and I ask you the question 3 times, I say, what are the coefficients A, B, and C? Then you would type in negative 1, 0, and 4. If there's not a number in front of the x squared term, you assume that it's a 1. And if it's a negative in front, you assume that it's a negative 1. Does that make sense? The B is 0 because there is no x part of this thing. And then the 4 is the number that doesn't have an x next to it. That's the way I look at it. Does that make sense? Okay, so I'm sure that people will get screwed up because I asked the question in a very specific way, but the reason why I'm doing that is because I can't tell the computer, when they put in this answer, grade it, right? The computer will be like, what the heck are they trying to do? I don't understand. And then someone's going to type in something differently than somebody else. Does that make sense? Yeah.
Remember the chat that we had about the no answer text provided questions? Did you take a look at that?
Yes, I did, and
Was it specific to me?
I will make sure to fix all of that kind of stuff. But why don't we get into chapter 2? I think I left off on page 17, I think. So here's what my request is. My request is today I would like to
You mean a higher grade?
I would like to do this. All right. So, page 17. Let's do this. Take out your pencils and papers. We talked about foiling. We talked very briefly on this thing right here. You can't see that, huh? Bummer. All right. Well, please work. This is plugged in. This is plugged in. This is plugged in. All right. Let's get this party started. We talked very briefly about this thing. X minus 4 times x plus 10 equals 0. All right?
Oh, yeah.
And for those of you online, can you see this? X minus 4, x plus 10 equals 0. Okay. So the way that you solve this is you say, all right, well, I had this demonstration. I forgot. I think it was Ikasia who was hanging out with me, and it was like A times B equals 0. If I could say A times B, some number times some number is equal to 0, then what can I conclude? And you folks told me that either A was 0 or B was 0.
Or both.
Or both. That could also be a possibility. But either one or the other. Does that make sense? And in this particular case, you're going to deal with the either-or statement. You'll very rarely deal with the both. But yes, you're absolutely right. The conclusion we can draw is if this times this is equal to 0, then this is 0 or this is 0. I apply that idea to this, and I'm saying if this junk times this junk is equal to 0, then I can conclude that either x minus 4 is equal to 0 or x plus 10 is equal to 0. We cool with that? Yeah.
I remember something about solving for the zeros of the quadratic equation.
Yeah.
Where let's say you factored a quadratic
Okay, speak up
equation.
because the microphone can pick you up, and then that would be good.
So I remember something about, I think it was from 8th grade,
Yeah.
maybe, that where we factored quadratic equations into something that looked like that,
Yeah.
and the zeros of that equation were 4 and negative 10,
Yeah.
because they made those two terms go to 0.
As we said. So that's actually absolutely right. The point of doing this is to find the zeros. Let me kind of think of a great application. Let me grab something. I'll be right back. I've got a cannon that I'm going to grab. Yeah, a cannon.
We'll get to blow stuff up now.
When you're learning from a physics teacher, he always has the coolest toys. So I have a little mini cannon. All right. let me get to the canon, because I want to talk about what you talked about. Let me finish this. Is everyone cool with this idea? And you can almost, actually, you can't even just almost, you can definitely take a look at this and say, oh, well, the answer is positive 4, negative 10. It's kind of like whatever's the opposite of what's in here. Are we cool with that?
So you're saying that at the same time, 1x is 4 and 1x is negative 10.
Right. It's either this or that. X will equal 4
okay.
or x will equal negative 10. Does that make sense?
Yeah.
And so what we're doing is we are, so you're saying that either x equals 4 or x is equal to negative 10.
Yeah, you're plugging 4 into the first one and negative 10 into the second one.
Yeah. Yeah, very good. Okay. So let's do a lab, or maybe something that basically, whoa, what happened to, oh no, is it, no. Okay. Well, let's do some kind of lab to kind of show you what the whole point of all of this is. One thing I want you guys to do is, what I was saying is, you can kind of, eventually after you get good at this, you can kind of skip this step instead of saying this is equal to 0 and this is equal to 0, and you know, you can kind of just take a look and say, what are the zeros? And you say, okay, it's 4, negative 10, right? Eventually you'll be able to get there. If you get stuck, please feel free to do that step. But yeah, I mean, get practice with it. You can go straight from here to here. And I'll show you a problem that might get you a little bit stuck. But hold on, let me show you what the whole point of all of this is. This is a cannon. It's a small little mini cannon, and I love it because I do a lot of physics experiments with it, and I have precise parts as to where this cannon travels. And so let me show you the cannon in action. I'm just going to put it right here. I'm going to fire it. Let's hit this thing right here. In fact, let's do this. Let's put a little right there, and then we'll go like this. We'll fire the cannon. Okay, keep watching it very closely. Oh, way too big. All right, so do me a favor. Can you hunt that thing down? I only have a limited amount of these little balls. All right, so what happened? It ended up being something like that. Actually, it ended up being much bigger arc than that. But I'd like to have something that stays within my chalkboard. Sound good? Yeah, you can move the boxes. All right. This parabola, so Mr. Dalday is actually not a trained math teacher. I just teach it for fun because Mr. Dalday is crazy like that. I'm a trained physicist. I actually study physics. I'm getting a master's in physics. I got my bachelor's in physics. And so we talk a lot about things like firing cannonballs and whatnot when we're teaching physics and when we're learning physics. And so this parabola is described by this equation. It goes like this. Write it down if you want. It's delta x equals v naught t plus 1/2 at squared.
So what's that? Change in x?
This is the change in x is equal to the velocity initial times the time plus 1/2 the acceleration t squared. Don't freak out. Don't freak out. Just hang. No, okay? I'm going to rewrite this a little bit. This is the part where I'm just kind of showing you where this stuff comes from. So maybe your math for now isn't going to be this hard, at least. I'm going to change this delta x to a c. I can if I want. I'm allowed. I can just say, from now on, whenever I see a delta x, make it a c. Is that all right with you? And let's make this b naught, let's make it a b instead. Actually, you know what? I'm going to make it a negative c, just because I can. And then see this 1/2 a? I'm just going to make that a regular a. Maybe what I'll do is I'll change the case of it so that way you don't get this a confused with this a. And instead of writing t's, why don't I write an x? Okay? And let me move that c over to the other side. How would I do that? I would just What is that?
Erase the
Erase it. No. How mathematically? How would I do it? Yeah.
Add C to both sides.
I would add c to both sides because it's subtracting c on this side. Is that all right with you? So I have 0 on this side equals ax squared plus bx plus c. This equation right here that looks really complicated for physics is actually in secret code the equation for a parabola. The only difference is that the horizontal axis we call the t-axis, which most likely stands for time. And it's saying as time goes by, this is the height of your thing. Does that make sense? So we're dealing with a parabola. And quite often, maybe not quite often, but sometimes we can get that parabola to look something like this. Let's see.
Vertex form?
No, this would be a different form. I forgot what, let's call it x minus m, x minus n. Quite often we can make this thing look like this. Yes?
Francis and Diamond are saying, can you open up your webcam's tab a little more?
Actually, I think that what it does is you can open up your webcam's tab a little bit more. Just take the corner of the thing and grab it and then drag it to be bigger, as big as you can. You can get it? Yeah, but you can't see the number next to the V. Which V? Is
Did that be?
oh, this thing right here? Yeah, that one? Oh, I'm sorry. That's a little 0. It's a subscript. In mathematics we use subscripts. It basically means a different type of velocity. Should I go into that tangent? All right, fine, I will. I'll make it real quick. Diamond was asking about what this little symbol is, and a lot of times, here's the thing that a lot of times that people in physics and in math do is they see things that they've never seen before, and they freak out, and they say, "My brain cannot comprehend this anymore because because I've never seen that Greek symbol with a triangle or something like that." So let me explain certain things to you. So I'm going to take a little pause, a little break. All right. A couple years ago, there's this dude named Taylor Lautner. You guys remember that dude? Who was he? I don't keep up with him.
Right?
He's still around, right?
Yeah.
Well, he's like super like buff.
Yeah.
Yeah. I think he's
Okay,
ugly, but anyway. And wasn't he dating like a really popular Taylor girl as well? Taylor Swift. So there was Taylor Swift and Taylor Lautner. They were hanging out. And say that you're friends with Taylor Swift and Taylor Lautner because you're cool like that. Right? This is just the people you cruise with, right? In fact, this is actually pretty relevant because, believe it or not, my name is Anastasia. That's my first name. That's the A. No, I'm kidding. My name is Anastasia. That's my first name. But everyone calls me Tosh, or at least all of my friends do. You call me Mr. Dalday. But everyone calls me Tosh. You want to know the crazy thing is my wife's name is actually Natasha. And growing up, everyone calls her Tosh. So imagine the conundrum that if you're hanging out with Taylor Swift and Taylor Lautner, you got a problem there, right? So what would you do? You would probably say, okay, you'll be TL and you'll be TS, right? So that way you're saying, hey, Taylor S or Taylor L, right? And that way if you say, hey, Taylor, they both don't go what? Like that. Or in my case, hey, Tosh, and then literally, you watch me and my wife, we're like meerkats, and we go, we both look like that. So what this subscript is doing is it's kind of distinguishing between this T and this T. That's a different thing than having something like this. That superscript is actually a mathematical statement. You're squaring that. That's an exponent. If I have that 2 on the bottom, though, that just means time 1 or time 2, or in this case, time 0, or in this particular case, v0. It means the velocity at the beginning. So whenever I say v0, that's what I mean. Does that make sense to you? A little bit less freaked out? The problem is in physics we deal with a lot of different velocities. We deal with the velocity you're moving at the time. We deal with the velocity you started off with. We deal with the velocity at the end. So one of them we call V final as VF. And oftentimes when we talk about the initial one, we use a VI or a V0. I like saying V naught, and that's kind of what that whole thing is. All right. Any other questions, freakouts, concerns? Yes?
Well, so that physics equation is the same as the quadratic equation, but...
It comes from the quadratic equation.
Oh.
Actually, the physics equation comes from the quadratic
What does
equation.
change in x mean? Like change in the y value? Of the
Okay.
x-axis?
Now we're getting into deep physics, and while that excites me, that might piss you folks off, so I don't want to... fine, I'll take another divergence, but this is the last one. The delta x, all that means is the change in. And all that's doing is it's basically measuring, like, how far you moved. For example, I am 2 feet away from this table over here. Okay? Or I'm 2 feet away from the end of this chalkboard. Now I'm 5 feet away from the end of this chalkboard. So, which number do I use? Do I use 5 or 2 to describe how far I moved? What do you?
3.
Use 3. Right, because that would make sense. That's how far you moved, right? I mean, so what delta x will always mean is it's always just a number. And the specific number it's talking about is talking about the final position minus the initial position, because that's what you want to talk about, is not necessarily where you are relative to where, to the end of the chalkboard. Really the important thing is how far you traveled, where you are relative to where you started. Does that make sense? So if I say, oh, I'm 5 feet away from the chalkboard, you'd be like, so what? Look how far I walked. I'm 5 feet away from the chalkboard. And you just be like, well, tell me where you started, and I'll tell you, wow, you walked far. Or I'll be like, well, you must have started 4.5 feet. You're just really fat and you get tired very easy, or something like that.
So it's like the first 0 or the first x-intercept and
Yes.
the distance from the first x-intercept
So
to
what we're doing is when we solve for the zeros, you can't see me.
No, I think he's talking about me.
Oh, yeah, no. Ta-da! Okay. What we're doing is when we solve for the zeros of a parabola, what you're finding is we always say, well, I don't know why I erased that. We always say y is equal to, let's do this, x minus 3 times x minus 5, or something like that. Let's say that the parabola that this thing describes is this parabola. And then I say, we solve this when we set y is equal to 0. Right? Well, what that means is when you're setting the height equal to 0, you're saying, well, what is the x values that give you a height equal to 0? Yes?
x3 or x5.
x3 or x5. So apparently this is 3 and this is 5. This tells you when this cannonball is on the ground. Which, if you think about it, back in the cannonball days, that's the only 2 most important pieces of information you really need to know if you're under cannon fire. Does that make sense? We came up with this mathematics because we were talking about invading armies, and here's the history of it all. So this guy, Isaac Newton, kind of came about and said, well, here's the equations for these parabolas and all of that kind of stuff. So this is the direct application of what you see. So this is why we're teaching you all of this crazy stuff. And you're thinking, wow, that would be amazing if I were going to be an artillery specialist in the military, right? But I plan on being a manager at Nordstrom Rack. You know what I mean? And I don't need to know about cannonball fire in Nordstrom Rack, unless, of course, it's Black Friday, and then things get crazy and stuff like that. And then I'll say, okay. I think I've even given you this demonstration before. Okay, fine. If you don't want to learn math because of my cannonball and all that kind of stuff, because I think that's crazy and cool, and you want to be a manager at Ala Moana or something like that, what if I said this? this is you, and this is dollars. So this is how much dollars you make based off of how many units you sell. You know what I mean?
So like,
Then you would want to know where your zeros are at. Because if you sell this many units, you know, or maybe this will be your E and this will be your dollars, as in employees you hire. Then you'll want to know where your zeros are at. You'll also really want to know where this point is at. And that's where we'll get into calculus, or at least I can even start showing you the beginnings of cool calculus. And I promise you I'll try to make it as easy as possible. In fact, that will probably be more of an aside. Are you thoroughly motivated for quadratics and understanding like what the point of all of this is? I haven't even finished my lesson. I've burned up, like, what time did we start? Like, burned up like 20 minutes of my time already. All right,
now
let's
I
do
have a
this.
compelling argument for why raising
Actually, you know what? I think I'm actually, let's see. All right, let's do this. Okay, let's see. All right, this one looks like a fun one. If you can't see my computer screen, which I know that you can't, none of you can. Don't worry, the people who are here can't even because the darn TV doesn't work. If you can't see my computer screen, I'm on page 17 of Algebra 2.7. I'll draw you guys the picture. You guys don't need to look it up or worry about it. All right, let's see what it is that they're asking. Below are the graphs of two quadratic functions, each with x-intercepts clearly marked. Note, no units are not the units are not necessarily the same. What are the coordinates of P?
Which one is that?
Okay, this is like problem, it's like section 2.7 in the quadratics thing. I'll draw the picture for you. And we'll talk about parabolas some more. And then after that, I'm basically opening myself up for cannon fire. And you guys get to ask me all the questions. And I'll try to come up with a creative way of teaching it to you without giving away the answers to your homework. Okay, before I get to my hypothetical questions, I've gone on too many tangents. Can you save that hypothetical question?
No, I
Okay.
Write it down.
Questions.
I know. Okay. Let's see. 1, 2, 3, 4. P, Q, R. Here's my question. I think I'm gonna do this. I'm gonna ask for no numbers. I don't want any numbers. Ax squared plus bx plus c. Is a positive or negative number?
Positive. Wait, no, negative.
Sophia says negative. Sophia also says negative. Two Sophias, both negative.
Whoa.
Is this a trick?
Yeah, see, I should have used this as an example. Sophia F and Sophia P. All right.
Yeah.
There were 3 Alyssas whose last name started with an O in my 6th grade class.
I
That's terrible.
had a
Alright.
Lucas in my 2nd grade.
That's interesting. But is A positive or negative?
No, it's positive.
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 Oh, so
Yeah,
Sophia's
I guess.
competing against Sophia. Now one's saying
Positive.
positive, negative. What are they saying online? I'm just curious.
Let me see.
Actually, and I
They're all
realized.
saying positive. Yep.
All right, everyone's saying positive, and the answer is yes. It's positive. Absolutely, it's positive because it's opening upwards. It's got a happy face. Got
I
it?
keep getting confused with whether the vertex
Because
pointing
this
down
is-
means negative or
What
whether
is
the vertex
C?
pointing up.
Equal to.
0, right?
No.
No.
Remember, no numbers.
Oh,
It's R, right?
What is C equal to? Yeah, C is
R.
C is R. C is, I mean, if you think about it, if my equation were y is equal to ax squared plus bx plus c, and I ask you, find the y-intercept, how do you find the y-intercept of something?
Set X equal to
You set x equal to 0. So if x equals 0 here, what would this first thing be?
0.
A times 0. Are you sure A could be a big number?
Still 0.
Still 0. What about B times 0? Oh, wait, that's 0 squared. What about A times 0 squared?
Still 0.
Still 0. Okay, so all of this is 0. So your y-intercept is really this C. Does that make sense to you? Which, in this case, it's R. I mean, it's the letter R.
C is y.
We cool?
Oh yes, use the y-intercept. So that's what that means. Okay.
If I had something like this, x minus d, or no, x plus d, x plus e.
Because the y-intercept is the constant, right? That doesn't depend on.
What are the values that d and e can be?
D and E.
See, I'm asking you theoretical questions. I'm not asking you like specific questions. I'm just asking like to get your understanding. What can d and e be? P and Q. Very good. I agree with half of what you said. P and Q. What I don't agree with is that they're both positive. P is what? P is negative. Awesome. You are 100% wrong. Which is wrong, by the way. I just say wrong because it makes you feel like, oh, I got it correct. No, I didn't. Actually, I got it wrong.
Why did teachers do that?
Oh, because I'm a jerk. Just, that's really the bottom line. Because it amuses me, maybe. I don't know. I think that what I do is I say absurd things and I do absurd things and I have absurd mannerisms because the best way that I like to learn is I like arguing with people. I like when I take a class, I'll go up to the board and I'll sit down on the board and I'll be like, this is what's going on. And they'll be like, no, this is what's going on. We'll go back and forth. And a lot of times if they point out that I'm wrong, I feel good about that because it makes me feel like, oh, you're right. And I'll never forget that experience. You know what I mean? To me, learning happens over experiencing things and arguing with people and going back and forth. So that's why I'll string you along or I'll tell you these absurd stories because they're all like experiences that you can hold on to. All right. This is a positive number. This is a negative number.
Oh yeah, because the actual 0 is negative p.
Because
over there.
if this is the coordinates, then p is a negative number over here.
Yeah.
So x plus p has, do you get it?
No.
I see.
Oh yeah.
Can I explain it?
Because the
All right.
x. is the
I'll throw in
actual
numbers so that people don't freak out.
So,
What if we do like x, I don't know, this is negative
Oh.
2 and this is x equals 4 or something like that. I don't know.
It isn't the plus p.
And
That's
this would
the
be
0, it's
x
the negative.
plus 2
That's the 0.
and x minus 4. Because remember, your zeros are kind of like, if I wanted to set that equal to 0 and solve for it, you would say, oh, that's x equals negative 2 and x equals positive 4, which corresponds to kind of this thing.
Yeah.
Does that make more sense to you now?
Yep.
All right, cool.
Okay.
That was a tricky one, though, huh? I made that off the top of my head. All right, let's see. Over here they have let's do that one. That one looks fun. All right, I'm going to change up the parabola. Let me see if you folks like this one. This looks like my cannonball, actually. And I'll tell you what, I'll give you numbers just because, allows people to freak out less. 1, 5, and 3. I don't know why I chose all the odd numbers. Okay, questions. The general form for a parabola is y equals ax squared plus bx plus c. All right? I don't want you to tell me what A is, but what I want you to know to tell me is A positive or negative?
Negative, because the parabola is facing down.
Negative. Because if I look at this like a face, this is a sad face. Okay. All right. Next question. What is C? You've answered too many times. What is C? It's -3, actually. I'm sorry, I should have labeled this. You're right. You're right. You're right. Very good job. It's -3. Very good. Okay. What does if I were to rewrite this and not write it like this, instead I wrote my thing in what we call factor form. Actually, I don't want to use A and B again. I'll use D and E again. What are the values of D and E? Yeah. Wait. You've answered too many times. I need somebody else.
-1 and -5.
-1 and -5. Exactly. Very good. Sorry, I don't mean to exclude you. I just want to participate everybody. Yes, absolutely. This thing is actually x minus 1 and x minus 5. And if we were to FOIL this, which we can pretty quickly,
Right.
Can you help me FOIL this? Have you gotten good enough in FOILing it so you can do it in your head? X squared minus 6x plus 5.
Yeah, I see that.
X squared minus 5x minus 1x plus 5. That minus 5x and the minus 1x combine to be -6x. We cool?
Yes.
So, this is the equation for this parabola. Yes. Great. Wrong again. No, I love it. I love that you participated at least. This is the equation for this parabola. No, it's not, actually.
Yeah, because the x is positive.
X is positive.
So that
This
makes
x squared
sense.
term has to be a negative, so maybe what we should do is slap on a negative in front of this whole thing. And why did I change the signs of everything? Well, it's because it's like I put I multiplied the whole thing by negative. Does that make sense? I can't just multiply one term by negative. That's not fair. So I multiplied the whole thing by negative. So what that does is it flips my parabola upside down. Because to be honest with you, when you folks wrote this first one down over here, you were describing a happy face parabola that crosses through those specific points.
Yeah, I was confused because you wrote x minus 1 and x minus 5. Oh, wait.
Yeah. And by the way, I'm going to erase this 3 because actually getting it to be 3 is a little bit funkier as well. There's a little trick to that as well.
Add an x.
This actually should be -5.
Yeah. Well, it's not drawn to scale, so.
No. But even if it weren't drawn to scale, I shouldn't put -3 down.
So add the negative to the formula if it's the parabola is the parabola.
So this would describe this parabola.
Okay.
And if we wanted to find the zeros, then I would, and if I gave it to you like this, then you could say, oh, well, the zeros are at x equals 1 or x equals 5. And you guys are saying, wait a second, well, doesn't that negative change things? Is that what you're asking yourselves? Doesn't this negative change things? Because,
Yeah.
if I have this, then what are the zeros?
-1.
No, what are the zeros if I have this right here? Without the negative.
1 and 5.
1 and 5. Agreed?
Yeah.
What is the equation? What are the zeros if I have this?
Just add a
Negative.
-1 and -5? As opposed to +1 and +5?
Yeah.
Cool. You're all correct.
Oh.
It's still 1 and 5. Because remember, when we're solving for the zeros, we set this thing equal to 0. If I have a negative out in front here, I can just get rid of it by multiplying by -1. Okay, fine. Multiply by -1. That would make this negative a positive, and then I multiply that by -1. What's 0 times -1?
0.
Still 0. Do you guys get it?
Yeah.
All right. Mr. Daldy is being tricky today.
He's in a mood.
Well, essentially, here's kind of what's going on. This might be a little bit of an aside, or maybe me explaining it to you deeper, is if I didn't have the 0, here's what that graph would look like. It would be a happy face parabola, still crossing through 1 and 5. Tossing on that negative, takes that parabola, and does what to him? Flips them upside down. Right.
Wait, so when you put the negative in front of x minus 1 times x minus 5, that doesn't change anything?
Well, all that did was it took the parabola. So what Sophia's asking is when I put the negative in front,
the negative?
all that did was flip this thing upside down, right? But
Maybe because
it still has the same zeros. It's just flipped upside down.
Oh, but so
The
you
red
don't-
parabola and the black parabola have the same exact zeros.
Yeah, so you don't distribute the negative to the x minus 1, x minus 5.
Yeah, you do. I mean, you could, but you know, we could just keep it outside. We don't need to distribute it. What do you mean we?
Like,
You're talking about put this negative in here?
yeah,
Sure, we could.
yeah, I want to see that.
All right, fine. You
Just
want to
to
see that? I'll show it to you then. This could be 1 minus x times x minus 5. This is it, the same thing. I just wrote it like this because it's easier to see. I'll challenge you then. I put the negative in here and the negative in here.
Oh, I see. I see.
So that would be negative x, positive 1. That's why it's 1 minus x.
Okay. I see that.
Let's see. Let's see if this works. If we find the zeros, and this isn't as obvious, you know, it's not as easy to find the zeros on this one. So let's go back to the old school. Either 1 minus x equals 0 or x minus 5 equals 0, right?
Oh,
So 1 is equal to x or x is equal to 5. I just took the x and put them up to the other side. Is that all right with you? See, look, the same zeros.
Yeah, I see that.
yes, yeah.
Okay.
I could dig it.
So x minus 5.
Are we cool?
Yep.
All right. Why don't we do this? I think that I'm pretty much finished with the graphing factored form. I'm pretty much finished with my lecture on this topic. I hope that I covered as much as I could with you guys without freaking you out. Let me recap, and then what I'll do is let me recap, do one example problem, and then what I'll do is I'll look over some of your homework problems, and I'll choose like one problem from each of these assignments that are coming up. So that way, at least, I'm not giving you your entire homework away, but I'm at least kind of showing you the correct format that I want things in and maybe the approach to it. Okay? And then after that, I'm going to open it up to just like questions. What do you want to ask me? And that will be our math class for today. And then what are we going to do in chemistry? We're going to do something awesome. And hopefully, is everyone here staying for chemistry?
No.
Oh, okay. Well, we're going to do something awesome with a little bit of people we have then. All right. My recap. What do I want to do? Okay.
Can I stay in the room?
Yeah, you can hang. Actually, what I might do is I'm going to do a recap, and then there was an interesting question that Bradley asked me. And do you folks mind that I keep going on all these tangents? I feel like they're relevant to what we're doing. If you feel like I'm telling too many stories, just say, Mr. Baldi, stop telling stories.
I had a math teacher who wouldn't stop telling stories, but they were completely irrelevant to math.
No,
I
I think my stories are relevant. The canon was very relevant,
they
right?
Are, totally.
All right.
But I'm talking about the other one that I had in 6th grade who was really, really
ax squared plus bx plus c. A, that does a lot to your problem. We've talked a little bit about it. If A is a positive number. What kind of parabola you got?
Smiling.
Happy face.
Happy face parabola. It opens upwards. Got it? If A is a negative number,
Turns into a frown like
frowny face parabola, it opens downwards. Right? Write this down. I'm not going to write down all of these things, but you should write this summary down. I'm just going over it. If A is bigger than 1, what is that parabola? What happens to that parabola? If A is 2 or 3 or 5,
It grows faster and appears narrower.
it grows faster, appears narrower. It's that thing where we were doing with the gummy bear, where we took the gummy bear and then basically you're making it taller, and when you do that, you make it skinnier. They had this gummy bear on sale one time. It was like 12-pound gummy bear, or like 3-pound gummy bear, or something like that.
Oh, I
You got that? You actually bought it once?
A is less.
That must have been epic.
It was delicious.
That must have been like I would have been sick after I ate that. Did you get that?
On the mainland, there's this amusement park where I'm from, and
Where are you from?
Oh, Pittsburgh.
Oh, cool.
Pittsburgh.
Pittsburgh.
What amusement park?
That's far from here. All right, cool.
And they give them out as like prizes.
Giant gummy bears. Oh man, I'm sure that I would be puking like orange, or I mean,
Puking
you always puke orange. I would
rainbows.
be puking like lime green for like a week after I ate that. It'd be epic. Anyway, I would love to have one of those for my science class or my math class where I could show like a giant gummy bear. No.
I think it would break though.
I think I'm
That
gonna
big.
buy a giant gummy bear just so I can make a YouTube video of something, and I'm no. Right, that'd be great. And then I'll be like,
Crazy remix.
now you die, and I'll push them together, and then he'll be, okay, but wait a minute, that would be, this is where your gummy bear is getting vertically stretched, and think of it like vertically stretched. A lot of people think of it as getting skinnier, and I tend to shy away from that, even though that is definitely what the parabola is looking like. But think of it like vertically stretched. And Mr. Dalton makes it a point to go over this, because I'll tell you what, later on, we're going to revisit this idea when we get to a much more complicated topic. It will have the same exact properties. And then you'll be like, oh, now I understand why he made such a big deal out of these gummy bears. Just letting you know. If A is a fraction, or even if it's not a fraction, if it's some number in between 0 and 1,
It grows slower
then it grows slower
and appears wider.
and it appears, we put that thing, instead of the Slim Fast plan, we put that thing on the Whopper plan. Right? Every day you're having a Whopper extra value meal or whatever. That thing gets fatter.
Yeah.
Your parabola flattens out. I like thinking of it as a giant gummy bear being crushed in between. I think, no! What does C do to the parabola?
It moves the y-intercept.
Up and
It moves the
up
y-intercept,
and down.
and actually what it does is it pushes the thing up or down.
Yeah.
Actually, no, I like your definition better. It doesn't push the whole thing up or down. It does, in a sense, but I think that's the best definition. Is it moves the y-intercept around. The C value moves the y-intercept around.
Okay.
Okay?
Yeah.
I think later on I'm going to get into the different parts of a parabola. If I wrote my parabola like this, y equals x plus h. I don't want to use h and k. I want to use x plus 8, x plus c, x plus d. What does c and d tell me? What could c and d tell me?
The points on the.
Yeah,
What if
the
I
x-
specifically set
x-intercepts.
this y
The
equal to 0?
x-intercepts.
Oh yeah, the x-intercepts stuff.
This tells me the x-intercepts.
Yeah.
Are we cool?
Just make it like opposite.
And putting a number out in front, like that,
Yeah.
positive 1, negative 1, 5, 10, any number, does that change the x-intercepts? No, it doesn't. Because remember, we're setting this whole thing equal to 0, right?
Yes.
So we could get rid of this a by dividing it by a, right? Right?
Yeah.
That gets killed. 0 divided by a is what?
0.
Still 0. So that A didn't make a difference. Does that make sense? What I did was, maybe my regular parabola looks like this. If I made A like some big number, it would be like this. Still the same exact intercepts, just the just I stretched it a little bit. But the intercepts stayed the same. Cool? All right.
Yeah, I see that.
What Bradley asked me, and this was a while back, and I said, I don't know how to answer it. It's not that I don't know how to answer it. It's a very complicated answer, I think. And I don't think I was prepared to answer it today, but hopefully I think I can, is Bradley was saying, hey, doesn't that move the parabola right and left? If C moves it up and down, doesn't B move it right and left? Question.
Bradley wants me to tell you that he's leaving to go get his passport today.
Oh, Bradley, I'm doing a lesson just for you. Can you give me like 5 minutes? All right, fine. I'll just tell you the answer. Okay. B does not move the parabola right and left. Okay?
Oh yeah, I remember having
That's when B does something very interesting, and I think what I probably should do is, you know what? I'll tell you what. I'll answer this. I'll tell you the answer now, but I'll show you the app later. B does kind of move it right and left, but it also moves it up and down a little bit. If you look at it, if you change B, what will happen is your new parabola will end up moving right and left along another parabola. I know, it's crazy. So like, if you change B and make it a big number or something like that, then yes, your parabola will move to the right, but it will also move, your new parabola will be here. It will move this center point along this parabola.
Oh.
And this is something completely not what you need in Algebra 2. I'm just answering Bradley's question. I don't even think Algebra 2 teachers teach this. I don't even know if Algebra 2 teachers know this. I know this just because, I mean, I like to study math in my spare time.
So it changes the parabola left to right, but also
it does kind of move the thing right to left.
So it moves the vertex up along the curve of the parabola.
Yes, and let me look for the app that I want to show you, and then maybe I'll give you like 5 minutes to play with it, or a minute to play with it. Let's see, PHET had a good one. I hope that I don't even know if your good Chromebooks can cover it, but parabola, let me see. Yes, equation grapher. Okay, here we go. I think it might require Flash, and I don't know if you guys can use Flash. But for those of you online...
Well, I think the big blue button thing requires Flash. So.
Okay. Anyway, I chatted to you guys a website, and for those of you who are actually here, why don't we take a break and we'll show you how to pull this stuff up. But this would be it's kind of an interesting one. Actually, let me play around with it to see if it works. And I wish I could get this darn TV to work. Sarah, is there a trick to this thing? Sarah? So no Nini? Oh, can you tap her?
Oh, we use these a lot.
Do you know how to get the TV to work? Come on up. Please do it.
It's just sometimes takes a minute.
Okay. No, it was a blue screen the last time. All right. Open up your computers. Go to, type in PHET in the search bar.
So when B gets bigger, it moves right, but it also, the center of it is like on the original problem.
Yeah.
Okay, what?
Now type in PHET. You can share. In the search bar for PHET, type in equation grapher. I think that's what it is.
PHET.
You folks should get something that looks kind of like basically a Cartesian coordinate system.
What's Cartesian?
Cartesian coordinate system basically means an x and y axis, 2 dimensions.
I see.
That comes from René Descartes, who was actually a mathematician, and he came up with this coordinate system, so they called it Cartesian coordinate system.
So it's at University of Colorado Boulder.
Yeah, PHET, type in equation grapher. Now, after that, I want you to play with the A and see what making the A, changing the A does. Play with that thing.
Should we download it?
All right. No, you don't need to download it. Do you guys play sufficiently with A? Do you get it? Yeah, press the play button. Does it work for you? Yeah, awesome. Play with the A. Okay. And for those of you online, you guys can go to this website. Now, what I want you to do is play with the C button. Does that do exactly what you thought it would?
Yeah.
All right, now play with the B button.
Okay, let's see.
Ooh, wait.
What?
Why? What is this one?
Play with the B button.
Why is it moving down?
All right, so I was mistaken. It actually, when you change the B button, it moves it along an inverted parabola.
Oh, so that's wrong.
Yeah, it's a little bit wrong. It moves it along this parabola right here.
So the inverse of the original parabola.
Yeah.
Okay.
So your thing moves up and down around this.
Curve of the inverse of the original.
Moving it along the inverse version of the original parabola.
Yeah, which is very complicated stuff. And it's not something that you need to worry about. That's just something that I'm answering Bradley's question. It does move it right and left, but kind of like that's not the whole story. Got it? Don't worry, the stuff I'm going to actually have you guys do is a lot easier. Okay, why don't we do this? Why don't we take a look at some of your homework problems, and we will, I'll open it up to questions at this point. And I think what I'll do is I'll take a look at some of your homework problems as to what's coming up and what's due, and that way I can make sure that you guys understand how I want you to type things into the correct format. And we'll spend like 10 minutes doing that because I want to take like a significant break before we do our chemistry lab today. Okay, let's see. All right, Algebra 2.5 or 2.3. Let me preview what that thing looks like. How does the graph of the quadratic function f of x equals 3 of x squared? Oh, okay. Let's see.
Oh, this one was easy.
Which one?
I think this one's 2.3.
Oh, okay. 2.3 is easy.
Yeah, it's just finding the range.
Is it straightforward questions? All right.
Although I was a little confused about the range at first, but yes, it could be kind of a little bit of a range.
All right. Let's do this one.
I mean, like, I got it and all, but I just wanted to...
All right. I'm going to do question 12, 13, and 14. Actually, I'm just going to do question 12 and 13 for you.
And we can turn off our computers, right?
Yeah. I think the question was y equals x squared minus 3. Okay? Oh. Okay. Y equals x squared minus 3. Happy face or sad face problem?
Happy face.
Happy face.
Everyone agree? Does it move up or down? It moves down. How far?
Negative
3.
Oh yeah.
So the domain are the allowed input values. The range is the allowed output values. Is there any restriction on the domain of this parabola?
Nothing under -3.
Yeah, I think.
No. No, there's no restriction on the domain of this parabola at all.
Oh, I was talking about the range.
I could tell you any x value, and you could tell me, you know, and any x value lies in this parabola. Is there any restriction on the range
Yes.
of this parabola?
Anything you can.
You cannot have anything under 3. Or if I wanted to describe the range, I would say the range is y is greater than or equal to -3. Yes, question.
One thing that I found out while doing the homework is that if you have a negative x or
A negative here?
yeah, or like a negative a value, then that makes the range less than
We'll
0.
we'll talk about
or
that.
less than
Let me get to that. All right. Is everyone cool with this?
Yeah.
So I think what I do is I ask you this question in 2 parts, and I say, which symbol do you use? Do you use the greater than and equal to or less than and equal to sign? And then the second part is which number do you use? So in this case, in question 12 and 13, I think it is, you would say this symbol, -3 is your number. Done. Got it?
Could you write a table?
Um,
to show-
You could write a table, but I mean that doesn't really give you the. This gives you all the numbers that
Oh,
you have. All right.
Like this.
Now, if I change the problem up a little bit and I put a negative out in front there,
That means the parabola.
what kind of parabola am I dealing with here? Sad face parabola, is it moving up or down? Or has it been moved up or down?
Down.
Down how much?
Anything
Down by 3.
less than
Good.
or equal to -3.
This is the graph right here. Got it? What's the range on this?
Less than or equal to -3.
So it would be y is less than or equal to -3.
So the equals is empty.
Yeah. Does that make sense?
Yeah.
So
oh yeah.
if the problem had a negative out in front here, that would just mean a down-facing parabola. Essentially, what I wanted you to understand is I'm trying to test whether or not you can understand that if changing this value makes your parabola happy or sad. That's all I really want to know.
Oh, okay. So
You know
is
what I
like figuring out the range of a parabola really important?
Is it really boring?
Is it really important?
Is it important? Yeah, it's important. It would be kind of like, here's a good example. If I have a cannonball, where can I stand so I'll be safe?
Oh yeah.
You know? And the domain is even important when you're talking about like the real world. Because like in our problems, in all of these parabolas, your domain is going to be all real numbers. There is no problems with domains in parabolas. Does that make sense? Because what I'm asking is, what x values are allowed to go in? Well, this thing is allowed to go out infinitely far that way and infinitely far this way. So is there any restrictions as any x values I can input? No, because even if it's way out here, that parabola still, has an x value out there. Does that make sense? On the range one, that's when it gets kind of interesting for parabolas. But what I'm saying is, in physical world and physical reality, this actually, the domain does make sense, because you'll have things like this. Where can I stand so that I'll be safe from this cannonball? And that's when I want to know the domain.
Anything above, farther there.
And I guess maybe the confusing part is we call this the range of the cannon, how far your gun can shoot or whatever, the range of it. When really probably we should have called it the domain, because the range refers to the vertical part.
Oh, I see. Domain refers to the x value.
Domain refers to the x value, range refers to the y value. All right, next part of your homework. Let's see if we can work this out. So that's that homework. That was pretty straightforward, right? Let's do something harder. That way, I hope that you guys, yeah, I hope you guys do well on this stuff.
I just made a bunch of stupid mistakes on the quiz.
Let's try 2.9. Let's see. Is that one hard? 2.9?
I haven't looked at it.
Oh. Okay. I'll do problem. Actually, I don't know if I'll do any of the problems. I'll just make up a problem. Here. 2.9. Here's a problem from 2.9. Or not a specific problem, but I'm just making one up. X minus 3, x plus 4. Actually, I think I have 0 equals. What are the zeros? Somebody else besides this half of the class tell me. So that would be like you. This half. Positive 3 and negative 4.
Yeah.
If I were to graph that, it would look something like this. Positive 3, negative 4,
There we go.
and it would be a happy face parabola. I don't really care about whether it's a happy face parabola or not. And what's the, I think the way I specifically asked the question is, what is the leftmost zero?
Negative.
Which one is on the left?
Negative 4.
Negative 4. What's the rightmost zero?
Positive 3. On my
Positive 3. So really what I
Oh.
was yeah, that's how I asked the question, but really, you know, like I'll ask this question is, what are the zeros? And I'm thinking, how can I have the computer give you a correct answer if you put in 3 or negative 4? I don't know. Maybe I can ask this to you in 2 different parts. And I'll say, which one is the leftmost zero? Well, that would be the negative 4. Which one's the rightmost zero? It's the one that's, you know, on the right side. Does that make sense? Because you'll have 2 different zeros. We're cool? By the way, I'm just curious to know, can a parabola have 1 0?
That would.
No, that wouldn't be a function.
A parabola can have 2 zeros, right?
Can it have? I think
Can it have 1 0?
No, because that wouldn't be a
It's
function.
like round
It
0.
would be like a vertical.
No, it can totally have 1 0.
Really?
I'll show you. Ready?
Oh, duh.
Oh.
Wow.
No,
I
and what?
What is the 0 of this function? It's right there.
That. Just that.
Okay.
It's just 1. It's 1 point. That's it. There's no 2 points.
How can you tell if?
Could it have no zeros?
Yeah.
How can you tell if a parabola has
Sure.
a certain number of zeros?
I think that's a discussion left for chapter 3 and 4.
Okay.
But there's actually a way. It's pretty easy to tell. Okay. All right. I'll answer your question. If the parabola is pushed up, I mean, you can kind of think of it like
Well, I mean, like if you just have an equation.
if I have a parabola that's pushed up
Yeah.
and it's a happy face parabola, how many zeros does it have?
It's pushed up. Along
Think about it in your head. If
the
it's
axis.
happy face parabola pushed up, how many zeros?
0.
Zero.
No zeros. 0 zeros.
Okay.
If it's a happy face parabola and it's pulled down,
Ah.
2, because it's
Yeah.
right. If it's a sad face parabola and it's pulled down,
0.
no zeros. Won't ever cross the x-axis. If it's a sad face parabola and it's not pushed up or down, it's got 1 0. Cool?
Like, what if you have equations?
An equation? Well, you can look at the numbers and the numbers will tell you. And I think we'll get into that deeply when we cover, like, I don't know if we're going to cover this. If we don't, I'll make sure to do a quick lesson on this because this is kind of important. The, what is it called? The vertex form of a parabola.
Yeah. I remember going over that.
When we do vertex form of a parabola. Yeah, and you should have done this back in Algebra 1.
Yeah.
We're
But
cool?
It was really fun.
I think that pretty much summarizes chapter 2, to be honest with you. I don't foresee any, like, major
We're
issues.
10 minutes to go.
Yeah, 10 minutes to go. Any questions? Jenna wanted to go over quizzers. Jenna? Any questions from you?
No.
Can I go to the bathroom?
Yeah, you can probably use the bathroom. I mean, like, do you feel like having me here actually helps you out? Or
Yeah, I think it does. It's nice to actually, like.
the only thing is I can tell is Will is bored. Is this, like, does this make sense to you?
Yeah,
or
I
is-
think this is kind of fun.
All right. Jenna, wait. Jenna, was Jenna going to ask? Jenna, can we talk about question 6 on the quizzer real quick? I finished the quizzer. I got that one wrong. All right, fine. I'll tell you what. technically, I don't want to talk about homework questions on the quizzer, but I promise you I would, so I will. And so what I'm doing is I'm giving you guys a freebie on your quizzer. But then again, you guys should have finished quizzer.
I did.
Algebra 1 review. Oh, no, that one's due tomorrow. All right.
Yeah.
Well, let's do it anyway.
I did make a
You did terrible?
Yeah. I don't know, I just made a bunch of really stupid mistakes that I probably shouldn't have because I felt I was really prepared. But, yeah.
Okay.
It's
All students now have 2 attempts on the quizzer for tomorrow.
okay. Well, thanks.
You can go back and redo it if you want.
All right. Thank you.
Oh, yeah, that was my other question. Is do you guys feel like, do you guys use the 3 attempts that I give you?
Most of the time, yeah.
Do you like use it and then you run out and you're like, man, I wish I had more. Do you want like 5 attempts?
No, that's a bit too lenient.
I try to do.
Well, I'll be honest with you. I used to give people unlimited attempts. I used to just be like, as many times as you want. That's fine.
Just as long as it doesn't beat.
Yeah,
this.
it's true. When he took Algebra 1 from me, it was unlimited attempts all the time.
Andre used to just like go question by question.
Yeah.
Making sure
And what that would do is that would make all the students like guess and check. And if I did a multiple choice, he would just literally go through every single one until he got it right.
But now this year instead, you're doing this thing where you give us the answers right after we take the test.
Wait.
No, not.
Oh,
No.
yes. I'm accidentally
Twice.
pressing that button. Yeah, that's for chemistry, right?
Yeah.
Yeah. Where I'll accidentally give you, I'll give you multiple
And then
attempts,
bring
and then
the
I'll give
class
you
that
like
gets,
all the
like,
answers
these.
right after you
From
take the
the
test.
first attempt.
I accidentally. That's a matter of me pressing a button. Anyway, let's take a look at this one.
Actually,
Question 6. Is this the right one, Jenna? It's the graph of 2 functions f and g represent the distance in miles of 2 runners. All right. So, this graph represents the distance in miles of 2 runners. I'll draw it up on the board. Because the TV still didn't work. Trying to go quick, because I do want my break. Here's another point. Graph kind of looks like that. G of x. Cool?
Yeah.
This point right here is 2, this point right here is 6. And here's how I would approach this problem. What's the equation of this line? This is actually a pretty good equation. Y equals
I know.
3x
I think
plus
I know.
3x plus 0.
It's just 3x.
So it's just 3x, really.
Okay,
Are we cool?
because of the slope,
Yeah,
The
the
y2
slope
minus 1.
is 6 over 2, which is 3, and the intercept is 0. Are we cool with that? I just pulled that right off, but I mean, that was pretty easy to do. Okay, second part. After we find the equation of this line, we can, and I think I told you G of, by the way, this should be G of x. G of 180
although this is
equals, what was it? G of t equals 180. What is G of t plus 50? All right. G of time
you just need
equals
to
180. What is G of t plus 50?
t plus 50.
Oh no, t plus 50.
It would be 180 plus 50, which is 230. Right? Because g of t is 180, so
Yeah, that's what I thought too.
but that's wrong.
Yeah, actually, you stumped Mr. Dalday. I stumped
Wait,
Mr. Dalday. I'm
but-
stumped. I'm trying to think of this.
Oh,
Okay,
oh,
let's do it like this.
oh.
Wait. So g of t equals 3t, and then so you take 180 plus 50 times 3 because you're putting that number into the function.
No,
Oh.
no. It's not saying that t is. See, the problem with that is if t were equal to 180, then you can just put 180
yeah.
right here.
Okay.
If I said t is equal to 180,
Yeah,
but t
g of t.
is equal to something.
that's not 180.
Oh, but I can figure out what t is equal to, right? Because which value of t would give me 180? There we go.
Yeah.
There we
Yeah,
go.
if you divide it by 3.
All right. So, what is that? That's 6, right? 60. T is 60.
Oh,
Making sense?
can you go by that again?
No, I mean, yeah, because 3 times 60 is 180.
Yeah.
So t must have been 60.
So that means
Ha.
this is 110.
So what I'm asking for is, what is g of 110? Well, all you do is you
Plug
plug
110
that
into the
into
equation.
there, and you have 3 times 110, which is 330.
Yeah.
Ah, that one was a tricky one. Made me think.
Wait, which is
Which makes me feel bad for actually solving it for you, because I actually kind of wish you went through that process. You know, struggled with it yourself, but I don't know.
Okay, wait.
Let me actually see if that's actually the answer I had the computer tell you it is.
How do you know?
Because I took it already.
Oh, okay. Anyway, the answer is 330. Oh, you know what I better check? Is now that I gave you guys 2 attempts, I better make sure that you guys can't see the answers. I better not make the Tejas problem. Oh wait, is this the quizzer? Yeah, the quizzer. I told you guys have 2 attempts and then it didn't take. So 2 attempts. And I'll only let you see the answers after the second time you take it. Now that makes sense. All right, everyone has 2 questions. You can take it. Let's take like a 10-minute break or something like that.
Although
we good?
It's already almost 2.
No. Are you guys done with asking me questions?
I think I got this.
All right, good. Good.
But
Was that fun,
There
interactive?
was one question on the quizzer that had to do with profit. Like where someone breaks even.
You know what? I'll tell you what. It's a quizzer, so I can't answer too many questions.
But I don't remember going over profit and stuff very extensively.
Oh,
I thought you said profit.
Oh.
profit
Wow.
is simply changing. You know how like instead of the y, we called it h for
Yeah.
height,
Uh-huh.
or you know in my Nordstrom rack example, I
how to
put
find-
dollars for the vertical axis.
Yeah, like how do you find where someone breaks even?
Yeah, it would usually the profit would usually be like how much you spend versus how much you made,
Okay.
or it's actually how much you made minus how much you spent.
Hmm.
And I think was that the race car one, like in Bangkok.
Yeah.
It was like you went to. I reworded that question because it was a poorly worded question. I think Tejas came in and no, it wasn't Tejas. It couldn't have been. He's not in my algebra class. Well, a student came in and asked me a question about that, and I realized, that question is poorly worded, so I reworded the question.
Okay.
Yes. All right. Talk to you later. Please tell me I recorded that.